Hello, today we are going to implement the queue data structure. Let's have a look. So first of all, what we do, we will create a template that is struct any name. We will provide QU. Okay. So in this template, we will have three different variables. One is integer value. So this variable will store some values. Okay. Say for example, I have assigned the size of this val variable as 10. Now I am creating two different variables. One is for uh, front, another is for rear end, if and r. Still now there is no memory space is allocated. Now we are creating some variable. So we will write struct q. Variable name is simple q. Okay. So that by the help of q variable, only q variable, we this is the variable of which is of struct q u type. Okay. Now we will create main method, void main, and inside main we will first assign these variables. So we will first assign this front as 0 and rear variable as -1, and they are accessed through a variable that is q dot front and q dot rear. Okay. So here we will write q dot rear and q dot front. Okay. Now we will create a switch case so that the thing can be called multiple time. So for that, while one, this is a this is an infinite loop. In this infinite loop, I will print that enter your choice. Enter your choice. For case 1, I will print NQ, en, as you know, insert operation in case of Q, it is called NQ. Then in new line will be Q, and then we will have third, we will have display, and in fourth we'll have exit. Okay. Okay. So according to this message, user will give input. So scanf, inside scanf we will take input the values. Okay. Address of a variable name is ch. Okay. And here I will declare the variable name as int ch. Okay. Now inside this we will implement the switch case. In switch, inside this will be there will be the ch variable will be there. Then multiple cases, case 1, and there will be a break. Here will be enq, enq. I am just creating a method named as enq. So the same case will be there. I will have this variable here, again here, again here. Let's have a look. NQ, then DQ to for DQ, DEQ, any name as per the requirement. These are the identifiers. Okay. And display, DISP. Display is a variable, and then in fourth there will be exit. the function library function, this is present in library. So this is case 2, case 3, case 4. So we look it from the next time we will just already will uh, I will write this code in before so that the time will be saved. Okay, so this is exit 0 and case last case, that is default case. Printf in default case we will print that enter the correct choice. Okay, so user will see this, and according to that, if some cases the user enter wrong choice, then we will take care. This default case will take care of that. Then what I will do, I will, so here this for exit, this break is not required, so we can delete this. So for this we will create the methods. So for void, okay, so then enqueue, then dequeue, and then display. Okay, void dequeue and void display, void disp in this case. Okay, so these are the three methods initially we are trying to implement the ISP. So we will again write the prototype for all these. We'll create the prototype. We'll declare the prototype. Okay, so we will declare it here. We will declare the prototype here. Semicolon, again semicolon here, again semicolon here. There will be no body for prototype declaration. So as we have used printf and scanf, so you will use the library function, that is stdio.h. So you will include, as include is a preprocessor directive, stdio.h, and another header file has include stdlib.h. Okay, so these are the two different header files we will include for our program. Now for in queue operation. So we are trying to implement this one. So this is like a queue at any point of time. These are the elements, and front is taking care about the first place or the position from where we want to delete the value, and the rear is taking care of about that position where from where we are going to insert, or after that or in that position we are going to insert that value. Okay, so for every time whenever we are trying to enqueue, we always take care about that the queue is not full. So when it will be full, we have declared the array as 10. So if the rear, that is the variable qr, if it is 9, then the value will be, the queue will be full. So here we will write if q dot rear equal 9, then we will say printf message, we will print a message to you euv q is full. Okay, so we will display message. In other case, in else case, we will just insert, ask the user to enter some value. So for enqueue, I have declared a variable int x. Okay, now I will ask the user to enter a value int x, enter a value to insert. User will insert a value, and I will scan it. Printf, and the variable, as I have declared the variable in integer type, so I will write %d and it is ampersand of x, and x will be placed. So before placing x, what we can do, we must increment the r. So q dot r equal q dot r plus 1. I will increment the r, or you can write just q plus plus q dot r directly. Okay, so you can go through the video, previous video, and you can able to see that. Okay, so how we can minimize the codes. Okay, so then q dot val, q dot val of q dot r. In this place we will have a value, that value is x. Okay, so this way we can enqueue the values, and during dequeue, whenever we can able to dequeue, when there will be some element present in the list. So how we will check it? How we will check it? We'll check if what is the condition. So say for example here, if the we have declared here r, if is 0, if is greater than, the front is greater than r, then that means the queue is empty. If front q dot f is greater than q dot r, then we can say that printf q is empty. This is the empty queue. Now in else case we will increment just, or if you want to in delete display the what value we are going to delete, so we can say printf value is, the deleted value will be which place, q dot value of the position, that is q dot front. Okay, so and we will increment the front, q dot f equal q dot f plus plus or plus 1. Okay, so this will be for dq. For display also, whenever we are trying to display the values, so we will again check if queue is empty or not. If queue is not empty, then we will come here and we'll run a loop. Actually we'll run a loop. So for a loop, this in this loop we will print the values. So inside for, I will create a variable I is start from q dot front, and I less than equal to q dot rear, and we will print printf the values are percental d, and the value at position q dot val of what, I. So the variable name here, it will be int I. So for better understanding, I suggest you to please go through the video that where we have explained in the previous videos, we have where we have explained the implementation of queue, how we are going to implement everything, every variable, everything is explained in more details. Okay, so this is all about the implementation. Let's have a look and run this code. Okay, if there will be some error, then we'll check it. Okay, here, okay, semicolon, expected semicolon at 9 number 19, we have not provided semicolon here. Yes, we have missed it. And look here, here it is red, and here in the message box we are getting semicolon here, expected error expected while before while. So errors are good because they tells us about where we have made a mistake. It can be typo or something else as per the rule specified. Okay, so we have again another thing, bracket expected, where we have a bracket is required. So it is saying printf for iq dot I, it is saying expected first bracket before q. Okay, q dot f Let us check it. So here, so we have printf semi comma is required. Actually, we have missed the comma. Okay, by mistake I have written here scanf. Okay, printf. I need to write cnf scanf. We are going to execute this code. Yes, it is running. For nq1, insert the value. Say for 11. Again, insert the value 50, 55. Again, nq 98. Again, nq. So for example, I want to display. Okay, let's have a display 11, 55, 98. Okay, okay. Now, if we try to dequeue, okay, if I press 2, yes, the deleted value is 11. If I enqueue display now, the value is 55 and 98. Okay, okay. So, uh, and again, if you try to delete, so if I delete it to again 90 is deleted. Even if you want to delete, it is saying queue is empty. And this time, if we try to display also, it will say queue is empty. Okay. So if I enter now 4 for exit. Okay, done. So this is the implementation of queue. Thank you for watching. If you have any query, you write in the comment box.